Okay, so I'm back. Now, as you started to play with that and put in your numbers, this is what you should have come up with, or something pretty close to this. You knew that if you have the small pendulum, we're calling that 10 centimeter pendulum the length of 1, and we're going to call its frequency 1 because it just went one time. But if we made the pendulum longer than that, by 4 times longer, we found out that its frequency was twice as slow. Okay? If it was 9 times longer, its frequency compared to the first one was 3 times slower, and then the one that was 16 times longer, its frequency was 4 times slower. In other words, it made, 4 times as many swings as the other one. Okay, now we're going to play a math game. The math game that I ask you to play is to look for a pattern, and I want you to look at the pattern up and down in those numbers. So 1 to 1, what happens there? From 2 to 4, from 3 to 9, from 4 to 16. As you begin to play the math game, as you think about this, you can ask yourself, how do I get from 2 to 4? Okay, and how do I get from 3 to 9? And how do I get from 4 to 16? What is the pattern? Well, the pattern is, what I'm doing is taking the bottom number each time, multiplying it times itself to get the top number. So 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. I don't know if we've talked about that in class, but when you do that to numbers, that's called squaring the number. So we find out that the length and the frequency is actually a square of the other. Okay? So let's fill the whole chart out. So then, if we fill out the frequency across the bottom, we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So then 5 times slower would mean we have to have a pendulum that is 25 times longer than the first one we started with. To make it 6 times slower, it would have to be 36 times longer than our first 10 centimeter one. 7 would be 49, 8 is 64, 9 is 81, and 10 is 100. And so that's really cool if you like to play in the math realm, to find out that the relationship between frequency and length is actually a square product. Or if we divide the top number to find out what two numbers multiply together to equal that number, that's called the square root. So remember when I had you graph those pendulum frequencies and lengths before? We ended up with a smooth curved line. The reason we ended up with a smooth curved line and not a straight line is because the relationship is not a one-to-one relationship. It is actually a squared relationship. So that's kind of heavy stuff, but that's really where I wanted to go with this. We have one more day of activities with pendulums, and that's next week, and then we're going to move on to something new. So now what I would like you to do is I want you to write a lab report for what you did in class on Wednesday and add to it what we did now through the podcast and the assignment this week. You should have a better understanding that the relationship between frequency and length is a squared relationship, not a linear or a one-to-one relationship. Remember, when you write the lab report, it has 3 paragraphs. The first paragraph is what you did, describe the whole investigation and all the things that you did. The second paragraph is what you learned. And then that's where you would talk about the things that are on this chart in front of you. And then the third paragraph is to identify the science and engineering practices and the cross-cutting concepts that you used that were the ones that were primarily used in the investigation. Don't just give it the number, actually write out the name of the practice or the cross-cutting concept and then explain why you think that those practices and cross-cutting concepts were used. Okay, that's it. You may submit your lab report online, or you can bring it to class next week. Remember, if you submit it online, you get extra points for doing that. All right, I'll see you in class next week. Thanks, bye.